Okay, so in yesterday's lesson, we learned how to integrate between two curves. Okay, just like how we integrated all the way to the x-axis, we just have to subtract the two curves. And that worked when we were doing problems with respect to x. And then we just discovered that sometimes that gets really messy, and so we've learned about an alternative way called with respect to y. How do you know when to do which? That's what we're going to talk about today. Okay? Most problems you can do either way, but usually one way is much easier than the other. Okay, I do want to remind you of this right here. This is kind of like just a recap of what we're doing in the 7.1. And so this will be, these are not formulas you have to memorize. Okay, if you understand what we're doing, it should kind of make sense. But that is something you can kind of refer back to if you're getting confused. Okay, and this was yesterday's homework out of the book. That's going to be due Monday. All right, so we went ahead, and this worksheet right here is basically today's homework, and only through number 11. I'll mention this again at the end, but this is something that we're going to do some of these together, and then you're going to finish it, and that'll also be due Monday. Okay, Monday we'll spend more time going over this and answering questions. So I want to kind of go through these steps in a new problem. So we have this one that we did. Remember, everything starts off with, though, can you graph these equations? If you're having trouble graphing, remember that you can always do T-charts, tables. You can use your calculator. We want to be able to do this stuff with and without the calculator. So let's look at number 2, and for a second, let's assume that we do not have a calculator. Okay, first thing is we've got to decide, is this problem going to be easier done with respect to x or with respect to y? Does anybody remember what we talked about yesterday? A good indicator that you probably want to do this with respect to y. The y squared. So because of that right there, this problem is going to be done with respect to, I just made up a new word, respecto. With respect to y. And you can use WRT for an abbreviation if you want. That's what I'll probably use from now on. What this means is that graph it however you need to, but when we actually get down to do the integral, everything's going to be in terms of y. Okay? I'm going to go ahead before I even graph, change my equations though. All right, because that may make even the graphing part easier. So some people get confused. They're like, why are you getting x by itself if we're doing with respect to y? Well, what I want is the body of the equation, the bulk of the equation, to be in terms of y. So you have to get x by itself in order to do that. So that's going to give me 2 minus y squared. And then the other one, what would that be? X equals negative y. Okay. What does x equals 2 minus y squared? What shape does that make?
A sideways parabola.
A horizontal parabola. Do you know which way it opens? Left. How do you know that?
It's a negative.
Because of the negative. So you learned how to do all of that in conic sections, right? And you remember everything from conic sections last year, right? Yeah.
Oh.
All right. So that's what I thought. So I'm going to pretend like we really don't remember that much. And we're going to, this is a good one to kind of use a T-chart. Now, if you don't need to do the T-chart, don't use it. If you're like, I can graph this just fine. Good for you. Do that. Okay. Now, because this is in terms of y, when you do the T-chart, plug the number in the y column first. Because otherwise, you're going to get confused as to what you should even try to let x equal. So if y is 0, then what does x equal? 2. So 2, 0 is, that's actually going to be the vertex of this parabola. All right, and again, I'm going to just kind of plug in some numbers. This is what you do when you're not quite sure how to graph and you don't have a calculator. This is what you have to do. So 2 minus 1 squared, that would be 1. And if y is negative 1, you get the same result. And so you can kind of see the shape of this parabola. If y is 2, 2 minus 2 squared, that's negative 2. And you can kind of start to see the symmetry, and if you do see the symmetry, it kind of saves you some work. So we have a sideways parabola. It's open to the left. It's shifted to the right too. All right, but I actually didn't really use much of anything about conic sections to do that. You want to make this parabola, you want to graph it as neatly as you possibly can. It will make the next step easier if your graph is very neat and you have lots of points. Okay, what about the second part? What shape does that make? What? It might have been more obvious if we had gotten y by itself. We don't really want to do that here, but if we had, it would have been negative x, a line. And it would go through the origin, and it would have a -1 slope. So we start at a y-intercept of 0, and then I go up 1 over 1, but in the negative direction. And if you graphed this super neatly, then you can see your intersection points. And the shape that we're trying to find the area of is right in there. And so I'd encourage you guys to use a highlighter to do this. I like highlighters as opposed to markers because it doesn't cover up the grid marks. Anybody want to guess what that area is? Not on this one. It's way easier. It's not your day.
4.5.
4, 4.5. 3.
3.8. Oh, no.
Okay. So we will find out really soon. All right. It's good to have an idea, because then if your answer is outrageous, you're going to be able to catch that. All right. So we also had this thing called an approximating rectangle. So I want to remind you, in the previous problem, we had a with respect to x, and we drew this tall, skinny, vertical rectangle, and that's going to help you set up the problem. What do you think my rectangle is going to look like on this problem? It's going to be horizontal because we have with respect to x. So anywhere you want in here, I'm not picking this part for any particular reason. And if you forget how the setup of the integral should go, you just got to think about what is the area of that rectangle. The base of that rectangle should be the right curve, which is the 2 minus y squared. And I get that there's an x equals there, but I want the body of the equation. Minus the left one, which would be negative y. So the base of this rectangle should be 2 minus y squared minus negative y. That's the base of the rectangle. Does anybody remember what the height would be? I'm going to give you a hint. In the previous problem, we had a dx. What do you think we're going to have here? dy. Okay, that's going to represent the height of this rectangle. It's the change, like d for delta, change in y. So if I multiply by dy, it's like base times height. Now that's the area of just a single rectangle. I want all the rectangles stacked bottom to top. So I'm going to not do this every time, but it's like you have all these rectangles. So you start at the bottom, and the y value at the bottom is -1. What's the y value at the top? 2. So we put an integral symbol. That means we're going to add all these rectangles up. The bottom bound is -1. The top bound is 2. I want you to really notice something here. These integral numbers are y values. The body of the integral is in terms of y. There's a dy. Everything has to do with y, including the bounds. That's where most people mess up here, is they have the wrong bounds. Okay, so what do the directions in this say about in terms of integrating by hand or in a calculator? What does it say?
Evens, odd.
Okay, so we get to use a calculator here. If you think you might have something stored in for x or y or whatever, go ahead and clear your variables. And then you can go F2 integrate. And then I'm going to actually just use, whoops. 2 minus, I'm going to actually really use y. And if you want to like simplify here, meaning if you want to use, say, oh, that's the same as plus y, that's fine. You can and you don't have to. It's just a preference. Okay, so there we go. It was 4.5. Good job.
Can you just like, instead of doing the little triangle thingy, can you just look at it?
The approximating rectangle, is that what you're saying? That's not going to be a required step. It's kind of like a learning step right now, but it's not something I'm going to require you to ever do to get full credit.
Okay.
So if you can do it without that, great.
Why did we do number 1 by Kelvin?
Because I got to just say, and we were running out of time. That's really probably the better reason.
But on homework, you want us to follow these?
Yeah. We're going to do 3 together in a minute, and we'll do that one by hand as well.
My calculator isn't showing.
What do you mean it isn't showing what?
So I put F3 correct, F3 then 2.
Uh-huh.
So
Okay, if your calculator ever doesn't have the, like, look up here, and if these tabs, does it say what mine say? Or is it different words? Okay, you're in like a custom window. So see where this says custom? At some point you have hit second home, and you have changed, you have tried to customize your home screen without realizing it. It was probably an accident. So if you hit second home again, it should turn it back to what mine looks like. See how mine's now screwed up. So I'm going to do second home, and now it's back to, whoops. Oh, there we go. Now it's how I want it. Okay, does that fix it? Okay. All right. Okay, here's what I would like for you guys to do. Turn the page, and I want you to go 3 through 11. I want you to, on your own, I'm going to give you 1 minute to do this. I want you to do all of 3 through 11 in 1 minute. Just kidding. I just want you to tell me, is it with respect to X or Y? That's all I want you to tell me. Which, do you think it would be easier to do with respect to X or Y? Just numbers 3 through 11.
I just wanted to say 7.
So 7 and 10, those are the ones that are Y's. Everything else should have been with respect to X. Keep in mind, you can do any problem either way in theory, but like why? Because WHY, the question. Because if you look at number 3, this one is going to be, we're going to do this one together now. With respect to X, if you did this with respect to Y, you would have to get X by itself here. Like, why would you want to do that? We don't even know how to do that. Okay? So, don't do that, basically. Okay, so number 3, how do you graph a cubic? You have an idea of what it looks like, right? It kind of goes up on one side, it goes down on the other side. There's probably a couple of curves in there. How do I graph this cubic? Very carefully. What do you do when all else fails and you don't have a calculator?
A table.
Make a table. So I want you to graph this cubic without a calculator. At least try to get 3 points. We are going to do it both ways. So right now you're just trying to graph the cubic by hand. however far you've gotten, what I want you to do now is get your calculator out and go ahead and type in y1 and y2. And we're gonna, and I know you guys can graph the line by hand, hopefully. And then just do a zoom 6. So a lot of times things like this will actually be graphed for you, or you'll get to use a calculator. But it is still really important that you know which one is the cubic and which one is the line in terms of like the top and the bottom and all that stuff. Okay, so combining what you did on your own and what you're doing in your calculator, what we're going to do now is transfer that onto the paper. I just did zoom 6, but if you go to F2, it's all the same zoom windows as your old calculator. Here's another thing. If you want to just trace, you can just trace to whatever, or you could go to the table. Let your calculator help you with coming up with these points. So like the points you should be graphing, I'm going to put up here. Okay, this is kind of our first example that we're doing of where the intersections are not pretty at all. The intersections are not whole numbers. So this would have to be a problem where you use your calculator. And so we're going to talk about how to use your calculator to help you with this. First off, let's go ahead and highlight in the shaded parts, and there's 2 of them. So how do you think that's going to affect how we do this problem? We're going to have to split it up and do the area of both and then add them in the end. Or why double it? How are you pretty confident that they're the same? So they are the same. All right, but the way you could be sure is by using rotational symmetry at 0,3, which you know, if I rotated that around, I would have the exact same graph. So you can be sure that they're the same, even without a calculator, but you may or may not even recognize that. But we're going to go ahead and say that they're the same, okay? So when I when I do this problem, I'm going to just get to go 2 times the integral of something, okay? And we can just do this one over here on the right. All right, we already said this is going to be with respect to x. So which type of approximating rectangle are we going to use? Horizontal or vertical? Which word sounds like it goes with x? Hoivux. Vertical. So remember, when you're setting this up, if you've forgotten, if you're like, is this left and right or top and bottom? If you've forgotten that, you just got to think, what are the dimensions of this rectangle? Okay, and the skinny part is always going to be like a dx or dy. In this case, dx, because with respect to x. Okay, the height is going to be top minus bottom. So it's going to be the line, which is negative 1/2 x plus 3, minus the curve, the cubic, which is going to be x cubed minus 5x plus 3. And then we multiply by dx because it's base times height. Okay, this is the same as doing top minus bottom dx. Now, for our bounds, I'm pretty confident that first bound is 0. I wish the second bound was prettier than it is, but it's just not. So this is where we need to use the calculator. It's the wrong one.
Wait, so does like the order matter? Because it's like
The order of what?
the two equations.
The order does matter, because if you put the wrong thing on top, it's going to cause your answer to be negative.
What if you do the top?
Then if we had picked the other part to do instead, because we're doing this part, right?
Yeah.
If I had picked this other one, I would get the same result in the end, and I would do the cubic minus the line, but my bounds would be a little bit different. So it would all work out in the end.
If you switch the order and you get a negative answer, can't you just make it positive since you know?
Yes, that would be an easy fix. If you get a negative answer, probably your mistake was easy. You just switched the two things.
Yeah.
It could be, though, that you did more than that wrong. So it's just good to check your work anyway. But yeah,
Okay.
you do always want to make sure, though, your work matches your final answer. Don't just leave the negative off of your answer. Okay. So we all know how to do intersection, right? You've done this on several after parties at this point. F5, intersection. First curve, second curve is just a quick inner, inner. Lower bound, does that mean below? It means to the left. And then upper means to the right. Okay, now this is a very ugly number. So we can't just round it and move on with our life. We've got to either use this whole decimal here, and it even keeps on going, or you can see how it says XC. You can actually, in the home screen, if you typed in X alpha C, it'll bring that number up. And then you could store it into any other, you could store it in for A or whatever. So those are options that you have. Ugh, I messed up. Whatever. I'm not gonna do that anyway here, but you could store it in for that. Okay, so this is something that also I'm okay with and the AP test is okay with. If you go ahead and you call this, say, A, and you write it down, the really long number, one time, you don't have to keep writing it. What you can do instead is just call it A. But you've got to list it somewhere on the paper, on the problem. So we could just put A here. Or we could write that decimal. Now, this is an odd, which means we get to, integrate this by hand. It's really not that bad. The first thing we need to do is distribute the negative. Okay, so if I distribute the negative, that's going to cause a negative x cubed. I'm going to go ahead and write that first. And then the negative half x minus negative 5x, that's going to make plus 5x, which is going to make plus 9/2 x. I'm just combining like terms. And the 3's actually totally go away. So that's what you would want to probably do. Probably simplify it before you integrate. Okay, then as we integrate, we just have negative 1/4 x to the 4th, and then plus 9 squared over 2 x squared. And then again, this is where calling that A is helpful, because then you can just write A up at the top. Then we need to plug in the upper bound. I'm going to plug in A in for x. Plug in the, keep plugging in the upper bound. And then are you confident that plugging in 0 is going to result in 0? So we could stop there. If you're not confident, then you need to write it out. So that's how you do that, integrating by hand. And then we did the times 2, because what's inside the brackets represents the area of this piece. They're the same. So this was definitely a step up. That's why I wanted to work this one out, because it had a lot of like little weird things that happened with it. They're not all like this. In fact, this problem just would have been a lot easier if instead of negative half x, it had just been negative x, so that these intersected, or I guess it'd be negative x plus 4. This would have intersected better. Well, then it wouldn't have been twice. So anyway, I could have made this problem nicer. I wanted to at least work one together that was kind of gross so that you'd know what to do. I'm going to stop here.